to achieve this. Oops, wrong direction. It's very difficult to modify proteins in a complex mixture, as Jen pointed out. Also, thinking ahead, as we become more interested in materials, we have to be able to scale these processes up. We have to think about how we're going to carry these out on kilo and probably 100-kilo scales in the not-too-distant future. And so that in chemistry, the way we usually define these reactions are process-type reactions, meaning reactions that are reliable enough and efficient enough that they can be carried out on gigantic scale. And I would argue almost none of the current bioconjugation methods meet these criteria. It is very common that we use 100 equivalents of reagent or 1,000 equivalents of reagent to get good conversion. When we do get that, we cannot separate the modified and the unmodified bioconjugates as well. And so these represent some technical challenges, but I think overall the point is we need a lot more reactions that we can use to modify proteins in various places. So I'll show two of those solutions we've come up with today in the context of the stories that I mentioned earlier. So one of the oldest projects in my lab involves the modification of viral capsids. This was a structure that captivated us my first year on the faculty. This is the crystal structure of a viral capsid shell, a protein shell, of a virus called bacteriophage MS2. This is a virus that's harmless to humans. It infects E. coli bacteria, and in fact is present in all mammals. It's actually a parasite of E. coli, which lives in the intestines. And this virus, we developed ways over the years where we could produce it with none of its normal genetic material inside. Normally viruses, this one would contain about 3,800 nucleotides of RNA. We can actually produce them such that that is absent, and we have these hollow protein shells that are left instead. These just have solvent on the inside, and what this presents for us are two surfaces that we can now modify. If we come in with one set of chemical reactions, what we want to do is modify the inside of this surface with a series of drug molecules or imaging agents.